Hey, what's up? Sergey here with another quick, hopefully Houdini tutorial. Actually, I've been playing Hogwarts Legacy like crazy lately. I've spent a lot of hours here. And I'm gonna give kudos to the developers team because it's the environment design and everything else is absolutely brilliant here. I think they're pushing Unreal Engine 4 to its limits, and it definitely pays off. But what funny thing that I've noticed is that a lot of elements of the environment, due to its magic nature, is actually procedurally animated. As you can see, the grand staircase, the famous one that you've seen lots of times in movies, and now with ultra HD settings in a video game, it's really fun design that you could just generate a shape and make sure it's procedurally generates the staircases, railings, any object for that matter. And I think that would be a great basic thing to discuss in Houdini, and that's why I'm thinking I'm gonna show you the basic setup that I've come up with to kind of simulate that particular effect. So let's dive into Houdini and discuss the further details there. Okay, so we're in Houdini now in its basic cylinder, and what I've done is, you probably can find in other tutorials on how to create procedural staircase or tower-like structures. I think Adrien Lambert has very vivid and detailed tutorial on his course with very intricate details in modeling, but I'm actually going to focus on two main things. First of all, the organic animation, and second of all, the power of expressions, meaning that you always have to be aware of what you plug where and what numbers you use, and try never to use non-relative links. Basically, if you use some absolute links or absolute numbers without any tie-ins to the actual parameters, that's going to bite you in the butt later on. So let's just take a look how it looks. And it's basic, simple animation of steps being extruded the way we saw just in the game. So you can see we have separate steps extruding, we have the railings appearing and following the steps, and then we have the railings pillars animated as well. Fairly simple setup, but as I mentioned, the power of expression allows us to go in to the very basic shape and adjust it the way we like it. Let's just say it's too low. Let's increase the height to 20 meters. Bam. So now if I continue playing the animation, it just goes on until it reaches the top. I mean, it might take a while. Or on the other hand, if we decide to go with larger scale and do it like this, as you can see, both railings and steps are adjusted, meaning we don't have any weird holes or nothing. It's gonna continue going on until it reaches the top. So let's just take a look again. I would say fairly nice. So let's try to quickly assemble it, because I'm already speaking for 3 minutes and we haven't even dived into that particular setup yet. So as you can see, it's not that hard, but I'm gonna remove everything. And oh, actually one more thing before we completely start over again. You could plug whatever model you want here. We just use a tube, but I, as a demonstration purpose, just carved out something with a revolve node, and we could replace it with those things, or whatever model you will go with. And that will obviously follow the animation as well. The same thing can be done for railings or the steps. So it's a very flexible setup, and that's why I encourage people to try to follow the principle of using the relative links and the parameters, rather than trying to put some eyeballing digits here and there. Okay, so let's completely remove everything but the tube, I would say. Oh, actually, what the hell, let's remove everything completely. I'm just gonna put a grid so that we have something to work on. Let's put it 25 by 25. We don't need any extra stuff. That will be our floor. Just call it floor. And we completely forget about it after that. Then we're gonna create our tube. Let's just say, okay, we're gonna do end caps. We're gonna copy the height. Place it at 0 at Y, divide by 2, make sure that it always at the bottom, not going in the negative Y space. And let's just play around with settings. So let's just say we start with height of 15 meters maybe. Oh, that's too high actually. Let's go with 10. Probably be enough. And the radius scale would be, I don't know, 3 maybe. Let's go with 5 as well. Let's increase the columns so that we have more detailed version of this. So now the only thing we need to do is the spiral shape to get our basic setup up and running. We're gonna do line, which is just basically generates a line. Then we do attribute expression because it has really nice feature of just generating the stuff we want before we even begin. So we can go for Y line to helix and then generate all the parameters. So let's begin our process of actually tying parameters one to another. We're gonna grab the height from here. We're gonna put it here. So now it's the same height. We're gonna grab the radius from here. We're gonna put it here. So now it has 0 turns. That's why it's kind of oddly shaped. You can play around with it. Like, I don't know, go like 5, 10. It doesn't matter because we actually never specify the point number here. So if I go with, let's just say 300 points, now you can actually see the swirly nature. We're gonna go back, we're gonna put a constant on the width so it doesn't change the radius while going upwards. And the amounts of turns is basically up to you. I usually just take a radius or a height for that matter and divide by constant just to specify how frequent I want it to be. It's up to you completely. So let's just enable this so that we can see. And we have to divide radius by 2 as well. I forgot about that. Cool. So we have our first completely procedural tied in here. So if I change the settings here, as you can see, this shape, this curve rather, remains the same. So let's do another thing. Let's drop attribute wrangler to create normals that points outwards. It's going to be easy done with just this simple expression. So now if we enable normals, you could see it's like going up, but we need it to be outwards. So let's just multiply it by this, essentially. That gives us really nice outward pointy curve. Okay. So let's now tackle the base for our steps. I'm just going to use the box, call it box 1. Let's just remove this one thing here. I'm just going to double check that recording is running. Okay, cool. Let's just come up with some random values over here. Okay, so the trick about this one is also make sure that this goes in a positive axis in all directions. So it's not like just in the world center, because we're going to copy it to points with a certain direction in mind. So let's just add a transform node here. I'm not going to do it in the box node, because if later on we decide to switch model with something else, those adjustments have to be made for all incoming geometry. So we're just going to translate it using the box expression, which just returns us bounding box of the object. And then we use the x size divided by 2, essentially. So that moved it in the positive x direction. Then we're just going to copy this for all other axes. Yeah, so now you can see it's where it should be in the end, which is nice. For now, we're going to leave it like this. And let's just do this simple copy to points, which you usually go with when you try to scatter geometry in the same way. So, and we're just going to drop a merge node here. Our base is kind of there. But first, what we need to do is make sure we kind of time procedurally the way that points are being generated for the amount of height that we see here, for example. What I mean by that is that if we decrease or increase the height of the tower, you can see that the gaps between steps increase or decrease. That means we have create a relative link between the height of the tower and the amount of steps to make sure we kind of negate that and it always be the way that we want it to be, essentially. So how to do that? Well, first we need to create like auxiliary setup to measure the length of our curve. Because the idea would be that we have our curve that, let's just get back to it, that curves around the tower. And we know the width of our step, which is right there. So idea is that we measure how long this curve is, and we just divide by the width of the step. That will give us the amount of points we need to distribute along the curve to scatter those steps on top of that. So I usually prefer to do it on a separate node tree, not here, so that, I mean, we can still link it together, but it will be easy for you to make sure it's just separate, and you could always control that separately. So I'm just gonna drag and drop this thing here. Let's just move our floor somewhere here for now. What do I need to do is I can completely remove the height. We don't need it. Basically what we need to do is make sure this thing just goes in the circles, right? Then we're going to convert it to a polyline, essentially, which is just a polygon. So let's just confirm that it has one prim here. And then we're going to drop measure node. That will give us the thing that we want. So let's just say root name area. I'm going to type primitive, sure, but we need to measure perimeter actually. So this is the thing that we want. So we're gonna go there in geometry spreadsheet, and this is our perimeter essentially. Cool. So what are we gonna do with this now? Well, what we're gonna need to do is go to a line node, basically the one over there, and we need to grab that perimeter and basically, as I mentioned before, divide by the width of the step that we created. So how to do that? Well, we need to address that attribute. We're going to use prim function, which, as the prompt shows, refers us to a specific node. Then we grab the actual prim number, then attribute name, and the index of that. Okay, so let's go and point that to our measure node. We need to grab well, we only have one primitive, so let's just put 0. Then we have to grab our perimeter attribute, and index will be just 0. So let's just confirm. It's pretty much the same, as you can see. There's a slight difference, but it's rounding upwards, so it's okay. And then we just need to divide it by the width of our box. I'm just going to copy the parameter here, and I'm going to paste the relative reference. So now we have some sort of relations here. So let's just double check that it actually works. I'm gonna go do a render flag here. And let's just change the, I don't know, the radius. Maybe the height as well. Yeah, as you can see, the gap at the very base of the staircase is always the same, which is nice. So basically that means we've tackled the issue of it being offset at every time we change the parameters of our tube, our tower rather. Okay, so what we have to do next is, you can see, obviously close those gaps on our steps, because it's weird that you have a staircase that have those weird gaps. We actually saw that in the game as well, that the staircases, well, steps rather, are kind of have this weird taper to it, so they enlarged outwards. We're not going to use the taper node, but we're going to quickly select the stuff we want on the side of our box, and then just use it as a as a drive for selection. So what I mean by that is, actually let's just call this node center so we not forget what's doing what. Let's get back to our box. I'm just gonna drop a group node real quick. We're gonna, let's check that. We're gonna use normals and use Z direction as well. It's just gonna decrease it to something like 75 maybe. I mean, this thing you will have to play around with, especially if you change the incoming model of the stair. I mean, unless it's already skewed in the way that you want to. But this is like the procedural way of doing things. And we're just gonna transform that and plug it here. We're just gonna call this group, I don't know, step side. Okay, and here we're gonna address that group, and this is gonna be side rescale. Oops. Cool. But we kind of have a problem because we don't know by how much we have to scale it. I mean, we can eyeball it always, obviously, but that's not going to be very procedural. So let's just zoom in real quick here and try to do it manually. So what we do here, well, you probably just have to adjust scale here to kind of close the gap. So at this point, it's like close to 0.4, 1.4, something like that. But if I change the attributes here, maybe like this, yes, you can see 1.4 doesn't really cut it now. So we need to find a way how to make this relation work. And we're actually gonna do the same trick we did with the first parameter. I'm just gonna duplicate that over here. The idea would be that we actually do the same measure twice with slightly how I mentioned with its quick change essentially. So I'm gonna go to our radius here. Actually, let's just, so that we never forget what's what, put it in the order that we've created them. And I'm actually gonna put a perimeter 1. Oops. Okay, so I'll never forget what I'm doing here. Perimeter 2. So in order for us to realize how big of the rescale we should make, what I suggest is that we take this, our initial radius, which is this one, and then we add to it the actual length of the step, so that we'll get our second radius, and we can get our second value that we can just divide by initial one and get the percentage increase that we need to apply for our rescale node. So, I mean, it's probably a bit complicated, but as long as you try to do it yourself, eventually you get to a point like, oh, it's actually pretty straightforward. You just need to try it without relying solely on what I'm showing you, but actually play around with it and come to a realization how it actually works. So, what we have to do, we have to go here. We have this our scale up and running, and then let's just add to it. Well, actually, I can just copy, probably. It could be better. Copy parameter. Gonna go here. Paste relative reference. Bam. So now we should have our second parameter over here. Cool. So we got our second parameter. So how will it help us? Well, instead of just scaling by hand, what we can do is grab that. Actually, I already had this expression somewhere. Hold on. Yeah, I'm just gonna grab this parameter expression from here, only this one. We're gonna change it to measure 2 because that's where our second parameter is. I'm just gonna double check. Yep. Okay. So now we're gonna divide it by the amount of points that we've generated prior to that. So this is where our first relation come into play. So I'm gonna copy parameter. I'm gonna paste it here. So this will give us the new width of our step. Well, I mean the actual in absolute numbers. So in order to get the percentage or change from that, we have to divide it by the initial one, which was 0.3. So I'm just gonna grab it here, go to the end, and we're just gonna divide it by that. So as you can see, it's at very close to 1.4, the initial scale that we came across. So now if I change something from the towers, I don't know, like this, as you can see, we don't have those gaps anymore. So the staircase is now closed. Okay, cool. Let's go back to our initial settings. I'm just gonna click save just in case. So now what we need to do is to adjust the height, because essentially what we have at the moment is our steps. Well, I mean, it depends. If we, hold on, oops, just gonna grab this one. As you can see, if we adjust this, it doesn't really change the distance between the staircase. So this is where we have to add additional, how I put it, additional parameter, essentially. This I'm just gonna rename it normals so that we're always aware what's what. Then I'm gonna drop another attribute wrangle. Okay. We're gonna call it step size offset. Let's go back to points. Okay, cool. And we're just gonna make sure we see what's going on here. So essentially what I want to do is to create a parameter that you can regulate based on the size of the step. Meaning that if we have our position and y, we're gonna do plus equals, meaning that we're gonna add it to itself plus something else. And then I'm gonna create a channel, which is float, because the size of the steps could be in decimals as well. We're gonna divide it by 2 and multiply by point number. Well, actually, let me just show you what we're gonna happen if we just leave it as this. Then we're gonna just generate an offset. As you can see, it just offsets all the points simultaneously. That's why we need to multiply it by point number. Yeah, and this time is actually, whoa, scales like hell. Okay, but we actually need the half of the size of our staircase to make sure it goes up the way it should. So what I'm gonna do is grab our box size Y. Then I'm gonna paste it here. As you can see, it just lifted for the whole length, and then I'm gonna divide it by 2. So we have just a very slight overlap, but it should be enough to close all the gaps. So if I increase the size, overlap kind of grows as well. But at least you always get the idea of that it's gonna be closed. You won't be able to see anything that, I mean, this is another problem that we're gonna solve at the moment, just don't pay attention to that. But this is the way that you can actually regulate the offset. I mean, you could do it manually as well. You can just delete the expression here and eyeball it if you want. But I would say it's much easier when it's procedurally tied to it and you don't get any problem with that. Okay, cool. So let's just tackle the issue of it's going above the height. So we're gonna just generate a condition. If our p.y actually oops, big one, bigger than, well, we're gonna create channel height actually for this one. Plus our offset here. Okay. Then we're gonna do the following. And the following is we're just gonna remove that point, essentially. Okay. So as you can see, we have a way to regulate the height, but it will be much easier if we just grab the height from our tube and make sure this is where our reference kind of reside. Cool. So now we have this staircase that it's fairly procedural. And it stays connected, which is nice. So let's go back to our initial thing. I'm just gonna save real quick. There's different ways to create railings. As I said, you could refer to Adrien Lambert's tutorial on YouTube. It has very in-depth work and much more prettier than my model. But nevertheless, we're just gonna quickly tackle that. So, okay, we're just gonna grab a transform node from here. We're gonna use our box size to offset it a bit. Actually, we could have gone with just copy transform, actually, because it's pretty much the same thing. Okay, so now we have this. Then we're gonna skin. That will generate our polygons. Then we just reverse them to point in the right direction. Okay. Then we can poly extrude them a bit. Oops. I'm just gonna put it 0.1, and we're actually gonna output back as well. Okay, let's just merge it and see what's going on here. So we created upper part, then let's just create bottom part. I'm just gonna use copy transform again, and I've set it from the same height of the step but downwards. Oops. So as you can see, it's kind of in the middle now there, which is nice. Okay, so now let's tackle the ones that on the outer side. The principle would be pretty much the same. We already know what we have to do. We have to grab the, well, actually, I'm just gonna grab copy transform. So we need to grab the initial base of our railings here, and we're gonna use the same trick with the radius to know how big of increase we need to apply. Which is basically means that we have to grab the this radius from here. Gonna copy parameter, gonna paste it here as a relative reference. Then we need to subtract the actual distance by which we extruded our railings, which we can grab from here. Paste relative reference. And now we have to divide by the initial radius that we were calculating before any increase. So we're just gonna copy this one. I'm gonna paste it over here. Just, okay, yeah, we shouldn't forget the actual brackets because we have a difference there before our division. So, and now we just copied the same thing to Y, to Z. Yay! So now we get this interesting shape, and then we can plug it over here. Let's just say, yeah, that's how it looks from the side. Let's just save. It's pretty nice. So it kind of already finished with the railings. You can go for a top side as well, just by grabbing transform, essentially. So we're gonna transform over here before one of the copy transform. We're gonna do the same radius treatment that we did here. Actually, we can just copy this whole thing. Okay. Pretty much the same. So we haven't generated our railing pillar just yet, so let me do this real quick. I'm just gonna put it here. Let's 0.5 meter, probably 0.3, I don't know. For now, I'm just gonna use it here, leave it here because we never connected just yet. And then over there, pass the relative reference, 0.5. Then we can actually merge it here. Yep. Okay. Gonna go out railings. And we're just gonna merge everything together. Okay, cool. Again, I'm just gonna showing you mostly rudimentary stuff, but the most important thing here is the actual procedural links in between those elements. So that if we decide to change something, then it's gonna be automatically updated and gonna work as well. And the difference is that we not yet animated it, but we will, and that's where it's all comes into play, that we have a separate incoming geometry for all the individual steps, railings, pillars, etc., etc. Otherwise, we would have a problem of it being extruded from the initial geometry, and sometimes it's not the best way of approaching the modular structure of some of the assets. So let's actually do the other copy to points for the pillars. So I'm actually going to grab transform from here, but we don't need the offset on height. Just going to grab the same points over here. And let's just grab copy to points connected to our tube. Okay. Okay, yeah, I forgot one more thing, is that we have to make sure it starts at 0 on positive y. Oops. Copy parameter, paste a relative reference, divided by 2, minus 0. Okay, cool. And then we just maybe make it something like this. Cool. Yeah, this is a bit of a problem. We need to make sure this is not... Okay, we have to go to our transform. Pull extrude wise. And maybe we need to divide it by 2, I think. Hold on. Oh yeah, because it's connected, sorry. Yeah, I should have broken the connection here, and we only need to increase the radius based on those ones. So I'm just gonna bring it over there. Okay. Gonna delete those by 2. And we actually have to edit here. Yep, okay. Now everything is lined up. Whew. Okay. I guess this is the biggest issue. You have to keep track of all the attributes and make sure you're using them correctly. Okay, cool. So we have our procedural base. So the only thing left to do is actually animate it. Let's just double check that it actually works. For all the combinations, nice. So now what we need to do is make sure we have the fancy way of animating it. So we can do it the following way. Is everything depends on points. I'm just gonna do attribute wrangle. Oops, attribute wrangle, come on. I'm gonna generate a condition. If our point number is greater than the current animation frame minus some offset that we're just gonna generate in a moment, then we're gonna do the following. And the following is we're gonna remove that point. Okay. Generate the offset. Let's see what it actually does. Yeah, okay, as you can see, and we have some sort of offset here. So let's now reconnect everything to that offset and see how it works. Okay, so kind of great. The only thing that we need to create additional animation for some of the different elements, let's just say steps, which is pretty easily done. We can just gonna go here. Now we're after the center. Say transform, and that's an asset level, so to speak. Anim. Let's grab first frame. We're gonna make it 0. And then, I don't know, frame 15, we're gonna put it to 1. By the way, I alt left click to generate a keyframe. So this is the animation of our step. And let's see how it fares on the larger scale. Well, we can't see anything in the moment, and this is because all our copy to points happens at the same time. What we need to do is to generate offset based on every incoming point. So what we have to do here, I'm just gonna grab this real quick and move it a bit downwards. Instead of just simply using copy to points, we have to go for each point. That will generate a loop for us. Let me, for now, temporarily disconnect that. I'm just gonna move it over here. Okay, so we're gonna input our points here. Let's just say this is time offset for points. Now, okay, let's call it actually time blast so that we wouldn't confuse ourselves, because the actual offset gonna be happening inside of the for each loop. Okay, then we're gonna click here and generate meta import, which we can actually switch from metadata to input. This is where our step's gonna come in. So this is step input. This is points input. And then we just create a meta node so that we have the information about each iteration that's happening. gonna call it loop data. Okay, and then we're actually gonna plug this copy to point node inside of the loop here. Okay, so now nothing happens just yet. But what we need to do is put a time shift node for our incoming model. And what we're gonna do with this time shift model is, well, time shift node is actually say, hey, you take a current frame, but you subtract the number of iteration to kind of counter the offset for every step. So how are we gonna do that with the detail? I'm gonna point to our loop data. We're gonna grab iteration with the 0 index, okay? So now, as you can see, we have that fancy offset. I mean, we can generate additional variable to control how large the offset will be, but I would say this is already in a good place so far. So let's just play the animation. Yeah, the only problem that it kind of feels like it's just the same shape. You know, when you see the loading animation of the circle, it feels like it's just a circle being rotated rather than animated. But we actually see that the steps being extruded properly right here. So we maybe just increase the offset a bit to play around with it. But to be pushing it a bit further, let's do the following. So I'm just going to grab the animation here, and I'm going to go to animation editor. I'm going to select it, and I'm just going to push it a bit to extreme to make sure we have like initial burst, and then it's kind of going to slow it down. So let's just take a look how it plays out. Actually gonna be very fast. Boo. Okay. So now let's take a look at the animation. Okay, we probably have to play around with animation a bit more. Hold on. Okay. There's not much we can do about the feeling of it being just a shape, because that's how it works. But as I said, we could potentially offset it a bit further to make sure that we have it in the way that we want. So now let's just do the same thing for our pillars. So we're gonna grab the points from here. The pillar is coming from here. I'm gonna plug it over here. Okay, the same thing. Actually, let me just do this. So we're gonna grab transform node, call it pillar anim. It's gonna be a step anim. And do the same thing. So I'm gonna alt click on scale Y, put it to 0. I'm gonna go 15 frames later, gonna put it to 1. Alt click it to make sure it's actually enabled as a keyframe. Yeah, and now you can see we have our animation for the staircase. I mean, it's fairly simple, as I said before, but the power of those connections can't be overestimated, I would say. So it's not that we spent, holy shit, 40 minutes trying to assemble that, but the problem is that you can easily readjust the parameters here Make it, I don't know, 5. And you can still see that our staircase remains the same. So we have this nice animation. Maybe you could speed it up a bit, play around with it. Anyway, maybe I've missed something that I haven't played around enough to make sure that it's actually protruding properly, as I said before. Yeah, the problem, we maybe can try to offset it a bit further to make sure it's a bit more drastic maybe. Let's try multiply by 2 maybe. Okay, so as I said, we're gonna generate additional parameter to drive how big of the offset we actually need. Yeah, you can see that it's much slower now and generates while the actual railings growing further. So it's a lot of attributes for you to play around with, but I hope this is enough for you to understand the base of how to create those assets and how you can actually drive those fancy animation. So yeah, I mean, if you have any questions or suggestions, please leave comment below. I will hopefully be able to answer them relatively quickly. Unless I'm gonna be playing Hogwarts Legacy, because it's still a lot for me to tackle in there. So that's about it. Let's just double check how it actually works in a game. Yeah, it actually connects from the 2 points, but I would say that when it drives from one point to another, it's much more interesting. Okay, cool. Thank you very much. Sergio's out.